with lines. All right, so we're gonna do some if-then things, okay? If I have a line crossed by a line like this, okay? All right, so let's talk about these angles just right here.
Oh, we did this last year.
What do I know about this angle and this angle? Ethan,
The same,
measurement.
yeah, that.
Why are they the same measurement? Abram, why?
Well, because if you have a straight line and you put another line in it, it's kind of, I guess we could say like collecting.
It's a bit like reflecting. Let's talk about these two angles, this angle and this angle. What do we know about them?
They're going to be different.
They're on a straight line. I'm going to call this one angle A and this one angle B.
One's obtuse, one is obtuse.
A plus B, if they're on a straight line, what does A plus B equal?
AB.
180.
A plus B is 180 because they're on a straight line and a straight line is 180. Do I need to know what A is?
No.
Do I need to know what B is?
No.
But I know that together they're 180. Always. Well, what about B plus C?
It's 180.
B plus C is 180. So if A plus B is 180 and B plus C is 180, what do I know about A and C?
180. Wait,
Equivalent.
no, they're gonna
Say it loud, Ethan.
They're equivalent.
They're equivalent, and that is why. Okay? They're equivalent because A plus B is 180, B plus C is 180, so A would have to equal C. Doesn't matter what A and C and B are.
No.
Right? Not right now. But we just know they're equivalent. What about B? What is it equivalent to? D equals what?
B.
B. Okay. Can I translate that?
Yeah, probably. I think.
I can translate anything I want. So, I'm going to translate it. Just like this. Okay, and we're going to call this A prime, B prime, C prime, D prime. And this is L1 and this is L1 prime. First of all, what do I know about L1? Okay, let's do these things in purple. What do I know about L1 and L1 prime? What do I know about them?
They're L1 and L1
They're
prime.
equal. They're parallel.
They're parallel. Why?
They're on the same line.
They're not on the same line. This is not the same line. That's not the same line. Why are they parallel?
They were just translated along vectors.
They were just translated along some random vector that I didn't even bother drawing up there because I didn't feel like it. Are they always going to be parallel if they're translated along a vector that doesn't put them on top of themselves?
Yes.
Yes.
Always. So I know if it was translated, they're going to be parallel.
Yeah.
Okay. So what if I have these over here? And I'm going to call them 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to call this one L1 and L2. If I tell you that L1 is parallel to L2, what do I know about these angle sets? They were translated. And so they're both going to be the same. Do you see how it works? Kind of backwards logic? If I'm translating them, that makes them parallel. If they're parallel, that makes them translated. And that is important. Because now we're going to look at stuff that we know about angles. What do we know about A and A prime?
They're the exact same.
They're the exact same. Why?
Because they were just translated along the
Because
line.
it was just a rigid transformation that took A to A prime. What about B and B prime? I'm going to use popsicle sticks. What do we know about B and B prime, Jacob? We have B right there. It was translated down, and there's B prime. What do I know about them? They're not, these are the angles. The angle of measure B and the measure of angle B prime. They're equal, right? Because I just translated them. So B equals B prime. What about, let's look at the C's. C and C prime. Isaiah. They're the same. C equals C prime. What about the D's? D and D prime. Radical.
They are the exact same thing.
They are the exact same thing. So, I'm going to teach you some vocabulary
Oh,
that goes with these, okay?
Not
they
vocabulary.
congruent.
Oh! There's a couple pieces of vocabulary. First of all, the word congruent, okay? If you have two angles with the same measurement, they are congruent. If you have two triangles that are the same everything, same size, same shape. By the way, can we just pause and appreciate how perfectly I drew those two triangles?
That was like,
Hooray!
Oh, I should do this thing. And I'm filming this one. That was amazing. You know what the beautiful thing is, though? I was about ready to flip it anyway, so it doesn't matter. That was choice. Woo! Okay, so those two, same lengths, same angles. These two triangles are congruent. So when we have numbers that are equal, right? Like 4 equals 4, I use an equal sign. When we have shapes that are congruent, I use an equal sign with a squiggly on top, and that means congruent. All it means is equal in shape land, in geometry, okay? So,
Wait, we're learning geometry?
so A is actually congruent to A prime, and B is congruent, and these are all congruent.
it's the same.
Basically, they're the same. Same size, same shape. Ooh, what if though?
What if?
What if? Okay, this black pen makes me soul want to cry. What if they're not the same color? Can they still be congruent?
Yes.
Do we care about color in
No.
math land?
No.
Not even a tiny little bit.
But still, those colors are superb.
We do care about color in physics, which is math's BFF, and then it matters. But
Wait, I thought,
this isn't physics class.
Can we learn some behind six?
Not today.
Oh.
Not you. Him, but not you.
Can we learn physics though?
Not today. Him, but not you.
Why not me?
I'm special.
Because you're not in my science class and he is. That's why. Because the 7th graders are doing physical stuff, science stuff. Anyway, so these angles, where we basically have, like, you see how this angle was translated down?
Yeah.
And this angle was translated down. And this angle was translated down. And this angle was translated down. Those are called corresponding angles.
So they move together. Or, I guess not move together, but.
If they are corresponding and we have two parallel lines, they're going to be congruent. If they're congruent, they aren't always corresponding. It's kind of like how all women are people, but not all people are women, right?
Wow.
Same concept, okay? So if these lines are parallel, these are the corresponding. So you just take it from this place and you translate it down, and it's like A prime. Does it matter if I call it, like could I number these? 1, 2, 3, 4, 5, 6, 7, 8. It's not A and A prime anymore, but they're still corresponding even if I name them different names.
It's true.
Right? Like if I got married
So one.
a while ago and I changed my last name from Belknap to Barlow, I was still the same person. I just had a different name.
So 1
Okay.
and 5 are still the same.
1 and 5 still have the same measure. Are they the same angle? No, because 1's up here and 5's down here, but they have the same measure, okay? Let's look at some other relationships though, because there are other things going on here. Like I know up here, right, that A and C are congruent, right? A is congruent to C. So if A is congruent to C and C is congruent to C prime, what do I know about A and C prime?
They're congruent.
A and C prime are congruent. Do you guys see that? This guy was, these are called vertical angles when they're across a thing like that. They're congruent because of the whole 180 thing that I showed you earlier. And then C is congruent to C prime because they were just translated. So A is congruent to C prime. What would I know about B? B is congruent. Is there one? Because this one is kind of on the outside, and this one's kind of on the outside. Is then B is kind of on the outside? Which one down here is kind of on the outside? That
B prime.
D prime. B is congruent to D prime. Okay. If I'm gonna paint the outside of my house, what kind of paint am I going to use? Interior or exterior?
Exterior.
Exterior paint for the outside of your house. If you're at the paint store, it's going to say, we're going to have a can of
That's a professional can.
exterior paint. When I painted my chicken coop, I used exterior paint. That's all I painted outside. I was going to paint a bench and then the bench fell apart when I was painting it. Because it was cold.
Oh,
Anyway,
that sucks.
squirrel moments. So,
Yay.
do you see how this kind of looks a little bit like an Oreo? Okay?
Wow.
You've got the cookie and the cookie, and then this is the creamy stuff. It's going to be a minty Oreo. This is the outside of the cookie. This is the outside of the cookie, okay? You guys, can you see it? Can you see the Oreo here?
Or it's a mini layer.
It's an Oreo with a line coming through it.
It's a chopped in half Oreo.
Braddock, I don't need you to comment on every single thing, okay? I love that you're participating, but maybe not quite so much, okay?
Okay.
Would this be the interior of the cookie out here? Or the exterior of the cookie?
The exterior.
Okay, so these angles are exterior angles because they're on the outside of my Oreo. But are they on the same side? Are 1 and D on the same? Are 1 and okay? So we have A and C prime. Are they on the same side?
No.
Okay. There is a fancy name that indicates that they're not on the same side. Okay. If you go to a basketball game and you have your team, and that's the team that you started with, and you need to switch to not the same players, what are those players called?
Subs.
Your subs or your alternates, right? Alternate means not the same. These are alternate exterior angles, okay? Alternate just means not on the same side. Exterior means on the outside. So we have 1 and 8. Guess what alternate exterior angles are? They're always congruent, okay? What about the angles on the inside? Okay, I've got angle D here. And angle, okay, so are D and C congruent? No. D and D prime are congruent. And I know that B prime is congruent to D prime because they're vertical angles, right? So if D is congruent to B, and then B is congruent to B prime, what do I know about D and B prime?
They're congruent.
So D is congruent to B prime, okay? These guys are on the inside. Which other two are on the inside?
4 and 5.
C and A prime, or 4 and 5. So C is going to be congruent to A prime. You guys see that? because C is congruent to C prime, and C prime is congruent to A, so they're congruent to each other.
So 2 would be
Wow.
congruent to 7.
2 is congruent to 7. We didn't do that one. But that's B and D prime. That's these two. We did do that one. So, if I'm going to paint the inside of my house, what kind of paint am I going to use?
Interior paint.
Interior paint. If these guys are alternate exterior, what would these guys be?
Alternate interior.
Alternate interior. Not right now. So they're alternate interior angles. And if these lines are parallel, the alternate interior angles are what?
Parallel.
Can you have parallel angles?
No.
Can't have parallel angles. But if the lines are parallel, the angles are going to be congruent. Okay? So much vocabulary today. We've got congruent, we've got alternate interior, alternate exterior, and corresponding. Okay?
This is English class.
This is math class, and we still have vocabulary in math class. We still need to describe what we're doing with words. Okay, now what if, for a second here, I have two lines that are not parallel. I'm going to say that line 1 is not parallel to line 2. Do I know anything about any of those angles?
Yes.
Which ones do I know things about, Braddock? I'm going to label them. 1, 2, 3, 4, 5, 6, 7, 8.
1 is corresponding with 4.
Congruent to 4. They're vertical angles. They're congruent. They're not corresponding. One's corresponding to 5. One's going to be, so we know that we have the vertical angles still. Is 1 congruent to 5? If it's not parallel? Is there a rigid transformation that takes me from 1 to 5 if those lines are not parallel?
Yeah.
If they're not parallel. If they're not parallel, there's no rigid transformation and they are not congruent. What if I don't know if they're parallel? Do I know if they're congruent?
Go back to first grade.
How do you know that something's parallel?
If it's going the same way.
Can sometimes things look like they're going the same way and they're not, if they're just a little bit off? So how do you know that something's parallel?
If they were translated on the same page.
If we tell you it was translated, or if we tell you they were parallel. Like seriously, you're gonna know it's parallel because I'm gonna tell you it's parallel. And if I don't tell you it's parallel, it's not parallel. Okay? Seriously. Because you can't tell. Can you tell by looking all the time if it's parallel? If it's just a little bit off? Like I guarantee you right now, because a human built this building, that floor, and that ceiling are not parallel, even though they look parallel. You discover all the not parallel things, like when you tile your shower and you're like, ooh, my shower's cracked, because none of the lines are parallel and nothing ends up in right angles, okay? And it looks parallel until you tile it. Same thing with things. Things are not necessarily parallel lines. So you can't tell by looking if it's parallel, but you can tell if I tell you it's parallel. Okay. So today on your assignment, we're gonna ask you just questions about all these different congruent angles, okay? Are they corresponding? Which one is corresponding? And you're gonna answer questions about this little group of angles. And what I did, because I love you and I didn't want you to have to flip back and forth, I just made the same little group of angles on every single page. It's not any different, it's just there. So you don't have to be doing this all day, okay?
And then you don't have to hear all day.
Well, I don't care if I hear that all day. I just don't want you guys to have a pain in the butt because it's a pain in the butt to flip back and forth. Peyton. Yeah, ask me a question because if you have a question, probably somebody. So, Okay, which translate? Let's look at this. I'm going to do number 2 for you guys because Peyton needs help with it, and probably if Peyton needs help, somebody else needs help too, because that's how it works. I've never ever had only one confused student. I've had a couple before.
What if you just have one?
I mean, I guess it could happen, but it doesn't usually. All right, so we're going to draw this. It says that these 2 were translated. If they're translated, are they parallel?
Yeah.
Yep. And we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Which translated angle corresponds to angle 1? I'm going to show you with a piece of plastic.
And the camera is just like.
Camera can just wait for me.
The camera's like, hey.
Camera's like, where'd she go? I'm back. So, if I translate this down, right? And I'm going to number it. 1, 2, 3, 4. And I translate this guy down.
Art master.
Which one corresponds to number 1?
What?
5. It's the one that number 1 was translated down. Which one corresponds to number 2?
6.
6. Which one corresponds to number 3? 7. Which?
8.
I'm gonna drop popsicle stick.
8.
Brad, be quiet.
Oh.
Carson,
Oh no.
which one corresponds to number 4?
8.
8. See how that works? Those are the ones that are corresponding. Is the ones where we translate them down and now they're on top of each other.
4 actually just got
And then it says
doubled.
that are they congruent?
Are they congruent? Let's do the thing. Jacob, are they congruent? If they're corresponding and it was parallel, and I just translated this one down, and now it's on top of there, are they congruent? Are they equal? Because congruent means equal. Yes, they're congruent. They're equal to each other. Okay? All right, I'm going to stop the video.
Yeah, 2 is